Assalamu alaikum dear students. Bismillahir Rahmanir Rahim. Welcome back. Dear students, I hope you will enjoy the first session that was related with the design analysis of determinate structures like beams. Okay. I hope you will enjoy those videos. I hope you will learn a lot of information from those videos. This is session 2. In this session 2 basically I try my best to analyze different types of indeterminate beams, clear? And I will solve 10 to 15 examples in this session as well. And inshallah in next session that will be I will distribute that session. Basically I you can say I delegate that section to frames, 2D frames. There may be determinate as well as maybe indeterminate. And next session inshallah we will study and analyze about trusses. So let's start. For this session I will also prefer to select examples from R.C. Hebler, that is the edition, and this is the chapter 10, and this is first example, which is a determinate structure of having a simple span, and a ruler at B and a fixed support at A, and a point load at midpoint, and EI is constant. I will cover this example as well as I will also cover this example. So I will cover these two examples in this lecture 18. So let's start. This is a simple beam, so let's select the units are in kilonewton meter. So you must select the appropriate units, that is kilonewton meter. Select the new template, beam template. You have only one span, clear? And the span length is, that is 6 plus 6 comes out to be 12 feet. So that is 12 feet. And you don't need grid spacing. And let's say delete this window, select this join, assign join, restraint, and this one will be fixed. Clear? This one will be fixed. Let's say check it. This is ruler. Clear? You can rotate this support in this direction, but it don't make any changes if it is in this direction or in this direction, because there is no incline loading. Assign the load, which is at the mid of the beam, 50 kilonewton. Assign frame load, point load. Make sure this will be 0. Modify. And force is gravity. And the magnitude at a distance of 6 meter, that is 50 kilonewton. Clear? And this one, F5 or do not run now. This is lecture number 18. Sorry, project number 18, lecture number 17, I think. This is the, now we first of all check the reaction, join. These are the reactions. Let's see, confirm it. 15, 112 and 34. Let's see, check the bending moment diagram. This is bending moment diagram. There is no shear diagram. If your reactions are okay, your shear diagram will also be okay. Clear? So let's see. If you are interested in shear diagram, select this. Okay, this will be the shear diagram, and frame moment about 3 3, select it. This is your moment diagram, and this is your loading diagram. Okay, 15 34 112. So okay, this is done here. Let's select the next example. The next example is this one. Okay, this is a fixed beam, okay, having a half UDL loading. Okay, so we will model it and we will analyze it. Clear? So selecting new model, the units are now this is this is the fixed beam, okay, and units are in kf feet. So kf feet. Clear? New template, okay, 1, and the span length is 10 10 20 feet. Clear? This is 20 feet. No need of grid spacing. Okay, delete it. Assign the both joints as fixed supports. Okay, these are fixed support. Assign the loading to the half span. Clear? Frame loading, selecting distributed load. Make sure this will be 0. Okay, modify. Okay, and kf feet, this option should be selected. You can select this one because before this load assigning up load, you don't apply any loading. Okay, so you can use this option. The gravity direction is okay, and here you can say at 0 you have a loading intensity of 2 kf per feet, and at a distance of 10 feet you have loading intensity of 2, and then at a distance of 10 feet you have 0. This is right up the half point. Okay, this is the midpoint. So one side, that is the left side of the midpoint, you have UDL, but at the right side there is no loading. So therefore we insert 10 equals 10 tens and 0. Okay, this is the loading. Press the analysis button. Do not run now. This is example number 19. Save it and see the results. This is the movement diagram. Clear? And if you want to see the joints reactions, these are the reactions. If you want to confirm it, let's see. There's a shear force diagram, moment diagram. This is the reaction, that is 16.25. This is the reaction. We will see this in later. Okay, so if you want to see the shear force diagram, select this option. Okay, this will be the shear force diagram, and if you want to see the bending moment diagram, this will be the moment diagram. So the maximum moment will be minus 45, that is minus 45. Clear? And if you want to see the loading diagram, so this is the loading diagram. This is the movement at the fixed supports, and these are the reactions, and this is the UDL. Clear? So this is the end of this lecture 1 of session 2, okay, which is related to indeterminate beam. So you see that you must know this is an indeterminate beam, because 1 2 3 4, you have 4 reactions, okay, and you have 3 equations of equilibrium. So this beam is basically 3-degree indeterminate. You must know this is fixed beam, and these there at B or at A you have 3 extra reactions. So this beam is 3-degree indeterminate, statically indeterminate. And the first beam which we will analyze in this one, this beam is 1-degree indeterminate. This reaction is extra, okay. This is, we can say in structural language, a redundant. So this is a redundant. This beam has a 1 redundant, or you can say this is 1-degree statically indeterminate, while the fixed beam is 3-degree statically indeterminate. Okay, if you have any question, any suggestion, any comments, please share your comments on my YouTube channel as well as on my email. Watch the video and enjoy. Thank you.